Okay, we're starting a new chapter, chapter 6. In chapter 6, we're going to do lots of things related to graphing and basically the study of the Cartesian coordinate system. A synonym for this is the rectangular coordinate system that we will build as we go on. Now, these are the objectives. You can read them over carefully. We'll be doing them as we move on. Now, one of the things that's important in this section is what we call an ordered pair. Now, an ordered pair is an x value and a y value, and because it's ordered, the order is significant. The x value will always come first, followed by the y value. And we'll build a little bit of a graph here as we go on. And let's do that together here in our notes. So if we have a vertical line and then a horizontal line, and these are actually number lines, and we're going to call the vertical line the y-axis and the horizontal line the x-axis. And as a number line goes, right here in the middle, the ordered pair is going to be 0, 0, which is the origin right there, so that values to the right of that are positive, and values to the left of this are negative. And then on the vertical number line, values above the 0 mark are positive, and below are negative. Now, they're going to have some nice graphs for you, but we wanted to build this. Now, remember, these lines extend to negative infinity in this direction, positive infinity in this direction, and then over on this side, we had from before, positive infinity this way, and negative infinity that way. So this is the Cartesian system, or the rectangular coordinate system, and each of these are ordered pairs. So what you'll be doing, and what they're going to ask you to do here, is to plot these ordered pairs. So for instance, a -2, 1, all of these are done this way. You start at the origin and you do the x value first, which is going to be a -2. So you go to the left 2, and then the y value is a +1, so you go up 1 and you leave a dot there. And this is a -1, -4, so -1, and then down -4 is there. And so on and so forth. For this one, C, it's 0. Again, this is our x value, and this is our y value. So you stay at 0, you just go up 2 and put a dot there. Now, I didn't make these equidistant, so it's just to show. So this is the first thing we're going to be doing, and you will, in your notes, be sketching some graphs. So they won't be too accurate, but hopefully sort of accurate. Now, we do have some stamps, rubber stamps, that you can borrow from the front desk and put these graphs, they're stamps that have a graph on them, and put them into your booklets if you like. Okay, let's go on then. So they're showing how to do this, and we've illustrated that already, and then this is what they would look like. Now, one thing I want to mention, and I don't see it quite mentioned here, it's probably mentioned somewhere, is that when we have a rectangular coordinate system here, it divides the plane into 4 regions or quadrants. The one up here, this is called the first quadrant. Then we go counterclockwise. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. And we use Roman numerals to designate the quadrants. Sometimes they will ask, which quadrant is point A in with these values? So you go to A, and you see it's in the second quadrant. And letter C is not in a quadrant, but we say it's on the y-axis. And if we had a point right there, that would be on the x-axis. All right, just some background and possible quiz questions. And they give you some more. And there they are. Now, an interesting thing you might note about this is that these all line up on a nice line here. Off in that direction and then this direction. Now, are there any other possible points? And we usually put an arrow like so. And you might say, yeah, there's points all along here that we're not drawing. And this goes off to, there's an infinite number of points in this direction and in this direction. So this is sort of what we're going to do. We're going to be giving you values as ordered pairs and ask you to plot the line. And actually, these ordered pairs represent an equation. And that's where we're going with this. So here we're just practicing placing these along in a graph, and then later you'll see there's going to be lines connecting them as you work this. I like graphing. All right, now in our next example, we're asked, and they work all of these out for you, but I want to show you a strategy for doing them. And for this, often we set up what is called a t-chart. So if you would in your notes, this will be our x value, this will be our y value. And they're giving us 3 points. Here this is 0, -2. And do this with me. This is going to be 2/3, 0, and this is 2 1/5. And this is the equation they're giving us to work with. Y equals 3x minus 2. So include all of this in your notes. The t-chart, the coordinate points placed in the t-chart, and they're asking us whether these points satisfy this equation here. Now, something else I'd like you to add to your notes as we go along. This equation, when it's in this form, matches this. Y equals mx plus the letter b. So write that in your notes. This form is called the slope intercept form of this equation, the slope-intercept form. When it's in this form, y equals mx plus b. So there's y, this is your m, and this is our b value. Now we're not going to deal with this right now, but I'd like you to start to practice and be familiar with some of these words that we use in Chapter 3. So then what do we do here? Well, we substitute the x with a 0. So 3 times 0 is 0, so y equals 2, and that's what they have here. So this one checks. Now, for this one, we have to put a 0 for the y out here, a 2/3 for the x here, and that's times 3 here. I guess I put the 3 there first. So 3 times x minus 2. So if we do the canceling here, we get 2 minus 2 is 0, so 0 equals 0. So this is a good one too. It's sat at these points, the first two sets, satisfy this equation. And how about this one here? So we're saying y is 5, 3 times 2 minus 2. So this is a 5, this is a 6 minus 2. Does 5 equal 4? No, so this one isn't 1. And that will be the answers. These satisfy, but this one doesn't. Alright, that's what this is all about here. And they go through in some detail showing you all of this. And they're substituting the 0 in there, and it does equal -2, so that point is true. I like the T-chart because it illustrates what you have, and then you can easily see if it works for you. And this satisfies, and then this next one is 2, 4. But the 2, 5 does not satisfy the equation. So if this were 4, it would. But if it's a 5, it doesn't. Now, the same thing applies for this one. But here they're not giving us all of the values. So once again, we want you to make a little T-chart and physically put this in your notes. X, Y, and we're going to have 1, 2, 3, 4 points here. And here, this is going to be a 0, this is going to be a 3, this is a 0, and a -2. Now the equation 2x plus 3y equals 12. I'd like you to write this in your notes too. That when it's in this form, ax plus by equals c. This is what we call standard form. Let me write it over here. Of the linear equation in two variables. So this is standard form, and this equation then is in standard form. So how do we solve it? Well, we're going to put a 0 where the 2 is here, where the x is. So 2 times 0 is 0, and we get 3y equals 12, just this part. Divide both sides by 3, and then y would be a 4. Then we're going to put a 3 here. So 3 times 2 is 6, plus 3y equals 12. We're going to subtract 6 from both sides. 3y equals 6, y equals 2. So over here we put a 2. Now for this next one, where y is a 0, 3 times 0 here is 0. Up over here, I should say. And then we have 2x equals 12. So x here is going to equal 6. Now I'm doing these perhaps a little quickly. Hopefully you're being able to follow. Pause if you'd like. That would be fine. And then for this one, we have 2x plus 3 times, this is a negative 2 for our y here, equals 12. So this is going to be a negative 6. 2x equals a negative 6. So we're going to add 6 to both sides. So this becomes 2x equals 18. X equals 9. So we have a 9 here. Now, if we were to sketch all of these points, they would give us a straight line, because this is a linear equation, and these ordered pairs are members of the solution of this particular equation. And we found them out through algebra. All right, remember you can always pause, check this out in some detail, and here's what they're doing here. So there's your first value here. So again, I like the idea of the T-chart where it kind of lets you see what you're doing, and you're getting your various values. And there's the last one. Okay. So I'm going to pass this up because I don't want this to be too long, and I think you have an idea of the T-chart. Mine's a little bit different, and I think more of the traditional. This is just another way of doing it. And in a similar fashion here. Now, for something like this, where you're filling things in, you can sometimes, they'll give you an equation, and this is a modified slope intercept here, where they normally you put the negative 2x first and then the 1, but that's okay. And there you can put some values out here and get some points. And you get your ordered pairs, and they're showing you how to work something like this out, whichever ones you're doing here. And when you do your ordered pairs, if they are integers, they're easy to put on the graph. Once you get fractions, you know, a circle involves lots of areas, a dot, so you could see it. So you have to be estimating a little bit here. And you'll see when you put them into your math lab, your Hawks software, that there is a little wiggle room. You can use your arrows to move the point to get to what you want. And that takes a little bit of practice. And that's what they're referring to here. Now, when you actually do a graph, and you only need 2 points to make a straight line. Sometimes when we used to do them by hand, we would say, plot an extra point, or solve for an extra point, so that you're sure you are in the right direction. I could recall years ago, sometimes students would make an error, and they'd have the lines going something like this. At this point would be up here, so their graph would go like this, and then all of a sudden, and that wouldn't be, that's not a linear equation. They have to all be in the same straight line. And once again, how many points are along a line? There's an infinite number of points, and you just selected some. Now the key is, you're looking for where they cross the actual guidelines of the graph here. Right there and there. It looks like right there anyway. Okay. Now, this one seems to be crossing the grid lines quite well. Sometimes, you get them like this. Let's see here. So it would be there. And now these would be fractions here. This might have been a point. I don't know. So you get the idea of what's going on. And these are just some others. That is, you have points that fall on the grid line. Now here it's not. So you'd have to estimate this one. And this would probably be a negative 1/2. And then it would be at a 4. This would be 3, so this one is 4. So negative 0.054. And you'll be having some practice with that here. So here are some practice problems. And we've already run 20 minutes, so we'll pass these up. And they do want you to do some T-chart work. You'll be doing that as part of your lesson. Okay.